So, hello students and very good morning. Today morning we are going to start the bonds parameters. Okay, now last class we have discussed up to the coordinate covalent bond, and today we will start with the bond parameters. Okay, in which we are going to discuss bond enthalpy, atomic radius, ionic radius, and all those things we are going to discuss today, bond angle and all. Okay, so if you are new to the channel, please don't forget to subscribe the channels and share with your friends. Okay, so let's start. So bond parameters. Okay, so bond parameters. Okay, so bond parameters, the first bond parameters we are going to discuss today morning is bond or length. Okay, bond length, or yeah, bond length. So what is the bond length? So if we want to define what is bond length, it is defined as equilibrium distance. It is defined as the equilibrium distance between the center of the between the center of the nucleus of two bonded atoms. Between the center of the nucleus of or nuclei of the two bonded atoms. Okay, now what does it mean? Let me tell you. Okay, what is bond length? Bond length is nothing but it is defined as the equilibrium distance between the center of the nuclei of the two bonded atoms. Okay, what does it mean? Let us try to understand. Suppose there is one atom, this one, and there is another atom, this one. Okay, so this is the nucleus of the atoms and this is the nucleus of another atoms. Okay, suppose this is atom A and this is atom B. Suppose what will be the radius of this? Suppose this is the radius. So we mark this radius as RA. Okay, radius of A, and this radius we are marking it as what? RB, that is radius of B. What is clear? So what is what is the bond length? Bond length is nothing but, you see here, the sum of these two distance. This distance, it will be called as what? Bond length. We represent it by R. So what will be it? So here bond length will be equals to what? Bond length is equals to RA plus RB. So that is R is equals to RA plus RB. So this is called as what? Bond length. Got it or not? So it is defined as the equilibrium distance between the center of the two nuclei, between the center of the two nuclei of the two bonded atoms. So this distance we call it as what? Bond length. Got it, dear students? Once again I am telling you, this is called covalent radius, this is also called covalent radius. When we combine these two, we get what? Total distance between the nucleus of one atom to the nucleus of another atom. So that one will be called as what? Bond length. So bond length is equals to RA plus RB, and it is measured in bond length we basically measured in picometer. Okay, we generally measure in picometer or angstrom. Got it? So bond length unit is what? Picometer or angstroms. This one you have to keep it in mind. So the first parameter today we have discussed is what? Bond length. And what is the bond length? It is the equilibrium distance between the center of the two nuclei, okay, or not, of the two bonded atoms. So bond length equal to RA plus RB, R equals to RA plus RB, and bond length ka unit is what? Picometer, or we can call it as angstroms. Okay, so this point is clear, I suppose. Okay, now we are going to see factors affecting the size of bond length. Okay, we are going to now study what are the factors which affects the bond length. Means what, whether bond length increases or decreases, on what factor does this depends. So the first factor we are going to discuss is bond multiplicity. Okay, factors affecting the bond length. Okay, affecting the bond length. Okay, factor affecting bond length. Number of the first factors we are going to discuss is what? Bond multiplicity. Bond multiplicity. Okay, what does it mean? Bond multiplicity means what? Bond length decreases. Here bond multiplicity means what? If the number of bond increases. Bond multiplicity means if the number of bonds is increased, multiplied, means you can say first it is one single bond, then it can be double bond, then it will be triple bond. Suppose bond multiplicity means if the bond number of bonds increases, then how does the bond length varies? We are going to see that. So remember, with increase in bond length, okay, with increase in bond length, what happened? With increase in number of bond, the bond length decreases. The bond length decreases. Okay, that means what? When the number of bonds is increasing, then in that case you will see that the bond length will be decreased. Okay, let's understand in this way. Suppose this is carbon. So carbon, here it is single bond. Okay, so let's assume that this one bond length, here it is 190 picometer. Example. Okay, this is not like that, but just example. Okay, another one is carbon double bond. So you will see that the bond has been increased or not. So the number of bond is increased, so here bond length will decrease. Suppose it may come to 120 picometer. This is not the exact value, I'm just telling you to understand. Okay, so earlier the bond length was single, so bond length was big, it was lengthy. Now this bond has been doubled, so it is bond length decreases, and when it is tripled, it will become minimum. Got it or not? So with increase in number of bonds, bond length decreases. That is the first factors. Okay, bond multiplicity. With increase in number of bond length increases. Bond length decreases. Okay, got it, dear students? Okay, so you can say that we can clearly see that the bond length of which one? The bond length of carbon single bond is greater than the bond length of carbon double bond, greater than carbon triple bond. Got it? So these points you have to keep it in mind. Okay, fine. The second factor we are going to discuss is size of the atoms. Okay, size of the atom. The second factors on which bond length depend is size of the atoms. Okay. So the bond length, what it will be? Increases with increase in size of the atom. Got it? So what happened? The bond length increases with increase in size of the atoms. Okay, to understand that, let us try to understand one thing. Suppose carbon single bond, another one is silicon single bond, another one is let's assume that germanium single bond. Okay, now if I ask you which one the bond length will be bigger, then definitely which one ka size is bigger, because bond length increases with increase in atomic with increase in size of atom. So which atom is bigger in size? So germanium. So this one ka bond length will be bigger than silicon, and this one will be minimum. Why? Because carbon, among these three, carbon is having the smallest size, so the radius also the what, so you will see that the bond length also it will be small. Got it? Here the size is big, so bond length also it will be bigger. Okay, got. For example, you can understand in this way also. This is carbon ka bond length. Okay, size is small. This one will be silicon ka bond length, so definitely it is bigger. And this one will be germanium ka bond length. So from here you can see, with increase in size, the bond length has increased. So these are the two factors which you have to remember in case of bond length. Bond length is nothing but it is the equilibrium distance between the two between the nucleus of the two bonded atoms. We have seen that. Next, what are the factors on which it depends? It depends upon, number one, bond multiplicity. With the increase in number of bonds, bond length increases. So that means what? The one which will have single bond, they will have higher bond length, whereas double bond little less, and triple bond will have the least bond length. The second factor we have discussed is what? Size of the atom. If the atoms, two atoms which are bonded, if the size is small, their bond length will be small. If the two bonded atoms are bigger in size, their bond length also will be big. Got it? That one I have shown it here. So hope, dear students, you have understood. You can pause the video and take down the notes. Okay. Next parameters we are going to discuss is bond angle. Okay. So bond angle is also very simple. See, in the board examinations and all, you will get 1 mark definitions from here, but in the competitive exams and all, it goes in details. Okay, they ask the questions from inside, so that's why it is very necessary to understand. Okay, the second factor is bond angle. So bond angle is what? So bond angle is the average angle between the orbital containing the bonding electron. It is the average angle between the orbital. Okay, it is the average angle between the orbitals containing the bonded electrons. Containing the bonded electrons. Okay, bonded electron pair. Bonded electron pair around the central atom. Around the central atom or molecules. Okay, what does it mean? We will explain to you. First, you take we can go through the definitions. So bond angle, it is the average distance between the orbital containing the bonded electrons. Okay, bonded electron pair around the central atoms or the molecules. Average distance. Okay, dear students. First, you take down the definitions. Okay, pause the video and take down the definitions. So bond angle basically it tells us about the shape of the compounds or the molecules. With the help of a bond angle, we will come to know about the shape of the particular compound molecules, okay, or not, or the compounds. It helps us in knowing the shapes. It also helps us in knowing the number of electrons, how the electrons are distributed around the central atom. That is the benefits of what? Bond angles. And one more thing you should note it, that is what it is measured in. Okay, bond angle is measured in, bond angle, it is measured in what? It is measured in degree or minute or seconds. Got it? So bond angle, it is measured in what? Degree, minutes or seconds. Okay, fine. Let me tell you by taking some examples, okay, of the bond angles. Like for example, methane. Okay, methane, if you see the structure of methane, it is one like this, and there are 4 carbons, right? So 1 carbon, 2 carbon, 3 carbon, 4 carbons. So here it is H, 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 H. Methane, there is 4 hydrogen, I mean to say. So what is the bond angle here? So this distance, the distance between the 2 bonded pair, this is one bonded pair and this is another bonded pair. So this distance we call it as what? Bond angle. The average distance between the 2 bonded pair. Okay. What is the average? It is the average distance between the orbital containing the bonded electron pair. So these two, the distance between these two, we will call it as what? Bond angle. And what is the bond angle here? 109 degree 5 minutes. Okay, 109 degree, 109.5 degree, sorry, 0.5 degree. So this is the bond angle of methane. Okay, and 109.5 degree means which kind of structure it will have, that one we will discuss in the later part of the chapter. Next, H2O, water. Okay, water, let us see how much, what is the bond angle here. So this is the central atom, H. So here it will be like this. Okay, so this is the bond angle of water, the distance between the 2 bonded, this is bonded pair and this is bonded electron pair. So the distance between 2 bonded electron pair around the central atom, this is the central atom, is called as what? Bond angle. So what is the bond angle here? 104.5 degree. Okay, got it? Okay, one more examples. Let us take ammonia. Okay, you have to remember the bond angle of these things. Okay, ammonia, NH, okay, 3. Got it? So when you draw the structure of this, then it will be like this. So here it will be H, and here it will be H. So this angle is called as what? Bond angle, 107 degree. So this is 107 degree. So what is bond angle? You have got the ideas about the bond angles. Okay, so bond angle is nothing but it is the average distance between the 2 bonded electron pair around the central atom. This is central atom, around this central atom only we are measuring the bond angle. So this is the bond angle. So what is bond angle? We have discussed. What is the unit of bond angle? Degree, minutes or seconds. And bond angle, what does it, what information does it gives us? It tells us, or it gives us the information about the structure of the particular compounds or the molecules. Okay, so I hope it is clear there, students. Okay, now you can pause the video and you can take it down. Next we will be moving on to the third parameters, bond parameters. Okay, the third bond parameter is very interesting and very, very important for your examinations. Okay. So what is the third parameters we have? The third parameters we have is what? Bond enthalpy. Okay, bond enthalpy. Now what is bond enthalpy? It is the amount of energy, it is the amount of energy required. Okay, it is the amount of energy required to break. Okay, it is the amount of energy required to break 1 mole of bonded atom, 1 mole of bonded. Okay, It is the amount of energy required to break 1 mole of the bonded, 1 mole of the 1 mole of bonds, 1 mole of bond of a particular, okay, of a particular types between the atom in the gaseous form, between the atoms in gaseous form. Okay, so what is bond enthalpy? It is the amount of energy required to break 1 mole of bonds of a particular types between the atoms in a gaseous forms. Okay, now so that is called as what? Bond enthalpies. So bond enthalpy, basically I'll tell you, it's nothing but it is just an amount of energy required to break the bond. In simple way you can understand this. For example, okay, for example you see like H and H. Okay, these two hydrogens, H2 molecules. In these H2 molecules, they are in the gaseous form. Excuse me. They are in the gaseous form. So this one we can write it as H2 also. Like this also we can write it. Okay, there is no harm in it. But in order to show you, I am writing it like this. So H2 I have written it like this. H single bond H. So how much energy will be required? Okay, how much energy will be required to break this bond? Okay, that energy we call it as what? Bond enthalpy. Enthalpy means what? The meaning of word enthalpy is change in energy. Change in energy. Okay, enthalpy means nothing but change in energy. Okay, dear students, so keep it in mind. So the amount of energy which will be required to break this bond, okay, and once the bond is broken, it will be separated. Hg plus Hg, like this it will be, right or not? So that amount of energy which is required to break this bond is called as what? Bond enthalpy, and it is represented like this, delta H. Bond enthalpy or enthalpy is represented by what? Delta H A delta A H naught, standard bond enthalpy. Okay, so it will have some value here. Got it? Understood? Okay, so bond enthalpy, I think you have understood. It is the amount of energy required to break the bond between the bonds. Okay, it is the amount of energy required to break 1 mole of bond of a particular type between the atoms. In which form? In the gaseous form. And it is represented by what? Delta A H naught. Okay, and the unit of bond enthalpy is the unit. Okay, unit of bond enthalpy. The unit of bond enthalpy is, what is the unit of bond enthalpy? Kilojoule. Okay, got it? The unit of bond enthalpy is kilojoule per mole. Okay, you have to remember this. So the unit of bond enthalpy is kilojoule per mole. What is the bond enthalpy? It is the amount of energy required to break 1 mole of bonds of a particular type in a gaseous forms. Okay, got it? So this point is clear. Okay, fine. Now we are going to discuss the factors on which bond, this is called bond enthalpy, or we can call it as bond dissociation enthalpy. Okay, got it? Bond dissociation enthalpy, yeah, we can also call it as bond dissociations enthalpy also. This is bond enthalpy, or we can call bond dissociations enthalpy. Okay, fine. So hope you have taken down. Now we are going to discuss what are the factors on which bond dissociation enthalpy depends. Okay, factors on which bond dissociation enthalpy depends. Okay, factors on which the bond dissociation enthalpy depends. The first factor is size of the bonded atom. The first one is size of the bonded atom. Size of the bonded atoms. Okay. So size of the bonded atom. So what will happen if the size of the bonded atom increases? Bond enthalpy will what? Decrease. Okay or not? Fine. So you can say one thing. Suppose I'll explain you. Suppose one carbon you have taken. Carbon ka bond. If you see the carbon ka structure, it is like this. 2 electrons is here, and carbon is this 6. 4 electrons are outside. Fine. This is carbon. Okay. Got it. Now, if you see that, let's take another example like potassium. Okay. So potassium K is there. What is the atomic number? 19. Here atomic number is 6. So potassium ka, if you draw the structure, it will be like this: 2 electrons. Here it will be 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons now. And it is 19, so 10, and then here it will be 1, 2, 3, 4, 5, 6, 7, 8. Got it? One more shells will be there. Got it or not? So 19 it is there. Now what will happen? So you see here, in this case you see the distance of the nucleus from the outermost electrons. It is very less. So what will happen here? The electrons will be attracted towards the nucleus strongly. Here the electrons will be attracted strongly towards the nucleus. But here you see the distance between the nucleus and the outermost shell is bigger or not? You can see it is bigger here. With increase in size of the atom, the distance of the atomic radius increases. The atomic radius, this is called atomic radius. So it is increasing or not? That means the distance between the nucleus and the electron is becoming long. Distance is far. Okay, they are far away from each other, right? The outermost shell and the nucleus, they are far away from each other. So it will be very easy to pull these electrons out. Okay, pulling out will be very easy. Pulling out of electrons, it will be very easy. Why? Because the electrons are far away from the nucleus. The nucleus is not having that much control on the electrons, so easily it will be pulled out. Easily pulling out means bond enthalpy, we don't need to apply much energy. So bond enthalpy here, it will be bond enthalpy will be low. Low bond enthalpy will be here with the bigger size, whereas in the smaller, here the nucleus is having proper control on the outermost electrons. The outermost electron is properly attracted by the nucleus. As a result, if you want to remove these electrons, then you have to apply more energy, more bond enthalpy. Got it? Bond enthalpy will be high here. Here bond enthalpy will be high because of the smaller size. The electrons are attracted towards the nucleus strongly. As a result, if you want to remove the electrons, then you have to apply extra energy. Got it or not? So how we will conclude? Size of the bonded atoms, with the increase in size, okay, of the bonded atom, bond enthalpy decreases. Okay. Okay, so what will be the conclusions? What we have understood from here? With the increase in size, bond enthalpy increases. Smaller the size of the atoms, larger or bigger is the bond enthalpy. So you can write here, with increase in size of the bonded atom, bond enthalpy decreases. Okay, so with increase in size of the bonded atom, bond enthalpy decreases, and with decrease in size of the bonded atom, bond enthalpy will what? Will increase. Okay, fine. So this factor, I think it is clear to all of you. Now let us move on to the next factors. Okay, so if I say in this regard, if I tell you which one the bond enthalpy will be high, carbon carbon or chlorine chlorine. Okay, so which one will have the higher bond enthalpy? Then you can say obviously the bond enthalpy of carbon carbon will be higher than the hydrogen hydrogens. Okay, okay, so which one is higher, having higher bond enthalpy? The bond enthalpy of carbon will be higher comparing to chlorine. Okay, because chlorine का size is bigger, so attractions between the electron and the nucleus will be less, whereas here the carbon carbon का size is smaller, so the attractions between the electrons and the nucleus will be more. As a result, you have to apply more power to take out the electrons. Okay, fine. So the second factor is what? The second factor is bond length. Okay, second factor is bond length. Okay, bond length. Okay, bond length, smaller the size of the bond, okay, smaller the size of the bond, higher will be the bond enthalpy. Okay, for example, you can say you just we write it, smaller the size of bond length, larger is the bond enthalpy. So this one, let us try to understand in this way. See, if the bond enthalpy, suppose if one is carbon carbon single bond, so here bond length will be big, and as I have already told you, with the increase in number of bond, the size of the bond length decreases. So here you see carbon carbon single bond. So if you are just, I'm giving you one example, if you are given one piece of stick, you will easily break it. Now if we combine that two broken part again, it will become, see, suppose this marker, I have broken it from the middle. Now the broken part, I will combine it together to break it. So now when it is doubled, that means the size of the stick is decreased. Earlier it was this much, half I have cut it, now I have doubled it, so now the size is decreased or not, so you need more strength to break or not. Same way here, if the single bond, it can easily be broken. So, okay, bond enthalpy here it will be less, energy required to break the bond will be less. Why? Because the bond length will be big. But when the bond is doubled, the bond length becomes small and it becomes very difficult to break. And even in the triple one, you will see the highest, that one bond enthalpy will be highest in the triple one, because the bond size will be bond length size will be very small. Okay, so always remember, smaller the size of the bond length, higher is the bond enthalpy. Okay, dear students, so take it down. Okay, hope you have taken down. Okay, so the last parameters we are going to discuss now is fourth one is what? Bond order. So for bond order, so what is bond order? Bond order is nothing but it is defined as the number of bond between the atoms in a molecules. Okay, it is defined as number of bond between atoms in a molecules. Okay, bond order is defined as the number of atoms, number of bond between two atoms, in a molecules. Okay, got it or not? So for example, here hydrogens, how many bonds are there? 1. So bond order will be what? Bond order will be equals to 1. Suppose carbon double bond, so what is the number of bond between carbon and carbon? 2. So bond order here it will be what? Equals to 2. Carbon triple bond, then what will be the bond order here? Bond order will be 3. Understood? So bond order is nothing but it is the number of bonds between the two atoms in a molecule. So got it or not? So whatever the number of bonds will be there between the two molecules, that one will be called as what? Bond orders. Okay, got it? So this is what we will conclude it today on this. Here is the end of your bond parameters. We have discussed bond angle, bond length, bond enthalpy, okay, and bond order we have discussed in these videos. Dear students, study the things properly. All the things which we have discussed today, it's very important. Okay, and yes, once again, if you are getting a benefit from this video and if you want to get notifications in the future for my new videos, then please don't forget to subscribe the channel. Thank you.